This is section 4.1. I'm not going to really go through the lecture notes. I am going to go through all of the examples. In order to do these problems, you're going to have pages. You're going to need pages from your appendix, specifically this steel design table. We're going to be needing that, and we're also going to be using some information on the different geometric shapes in the back of the book. Okay, so let's start on this welding application. It says calculate the weight of the welded steel beam. So I want you to notice something about this diagram. On the very top you see a plate. This is a steel plate, and its dimensions are 8 feet long, 38 inches wide, and 3/8 of an inch thick. The beams that are on the bottom, there are two different configurations given here. You'll notice that the two end shapes look like this, and then there's this center beam. Looks a little bit differently. Now, these beams are described by a certain kind of a reference that's used, and you'll see that in the steel table in just 1 second. This one is referred to as a C5x9, and you'll see what that means again in a minute. These numbers 5 and 9 mean something, and this over here is referred to as an S5x10. So the plan here, if we're going to get the total weight of this entire beam, is we're going to have to find the weight of the top. We're going to have to find the weight of this portion down here and double it to pick it up on the other side. And we're going to have to find the weight of this guy here. And then we're going to be adding all of those things together. So that's my plan. So, and I'm going to write that down over here. I'm going to find the weight of the top, and I'm going to add that to the weight. I'll call these the sides, the weight of the sides, plus the weight of the middle, this middle beam right here, of the middle. So that's what my plan is. So let's do the plate. So let's talk about the weight of the plate, the weight of the plate, or the weight of the top. Okay, if you look over in the appendix on the table pertaining to it's the steel design table, we're looking at a steel plate. And there's a box over here that has metric measurements, and there's a box over here that has English measurements. Now, our plate here is 3/8 of an inch thick. So we're going to be concentrating on this right here, right here. Now, this table tells us that if you have a plate that's 3/8 inches thick, that it weighs 15.3 pounds for every square foot. Pounds for every square foot. Well, let's look at the measurements of the plate. It measures 8 feet by 38 inches. Well, if I'm going to have to find the area of this plate, I'm not going to be able to deal with both feet and inches. So because the table calls for square feet, I'm going to go ahead and change the 38 inches to feet. So let me do that. Turn my calculator on. So I'm going to take 38 and I'm going to divide it by 12. And I get 3.1666 and so on. So let me put this down over here. That the width of that is 3.166 and 6. That's good enough. Take it out 4 places. So for me to find the area of the top, I'm going to be multiplying the 8 feet times that, and I already have this sitting here in my calculator. So let me just go ahead and do the math. Times 8. And I get a top area of 25.333 and so on. 25.333, and we'll take it out 4 places. Now, according to the table, I'm going to have to multiply that by 15.3 in order to get the weight of the top. So times 15.3. And again, I have this sitting in my calculator, so I'm just going to leave it there and continue the problem. So this is going to be times 15.3. So I get 387.6, and these are pounds. So that's the weight of the top plate. Now let's take a look at this shape right here, and let's find it on our sheet, our steel design table. And you can see that guy looks just like this C channel right here. Looks just like him. Certainly not like him. certainly not like him. And you might as well notice right now that this guy is the same shape as this one, and it's certainly not like him. So this is referred to as a C channel. And let's look at this this diagram here. You can see that W represents the width, the distance between this edge and this edge, and D represents the height from the very top to the very bottom, and T represents the thickness of this channel. So again, we've got information in the table. It's metric and English. Now, our information here is that this guy is a C5 by 9, a C5 by 9. And you can find it right here in the English part, C5 by 9. Now notice that the title of this column says that it's D times the weight. Well, what did we say D was? We said that D was the distance from the very top to the very bottom. And so this is 5, I'm assuming this 5 inches high. And we can see it right over here in the second part of the table. This is T, that the dimensions of this kind of a beam, this kind of a channel, is T by W by D. See the 5 right there? That's my D, and it's all in terms of inches. And for this particular kind of channel, the W, the width from this point to this point is 1 7/8 inches. And the thickness right in here is 5/16 of an inch. So the information is all right there in our table. Now, for this kind of a beam, it says that it weighs 9 feet, that's this 9 guy, 9 feet per lineal foot, for however long it is, 9 feet per lineal foot. Well, let's look at our diagram. This beam here is 8 feet long. So all I need to do is go ahead and multiply 9 by the 8 feet. So I'm going to say that the weight of my S5 by 10, and oh, by the way, I have 2 of these guys, remember. It's going to be 2 times, it's 8 feet long, times, what they say it was, it's 9 pounds for every foot. So by 9. So I've got 2 times 8 times 9. So I get 144, and these are pounds. These are pounds per square foot. 144 pounds. So far I have this top guy is 387. This guy and this guy, because I doubled it, is 144. Now I have to find this center guy. Well, we already said that this is the guy right here. And he is an S5 by 10. An S5 by 10, and so he's right here. So according to this guy, he's 5, that's the height, and he's 10 pounds for every running foot. And these are the dimensions of this shape of a beam. So I'm going to be multiplying my linear feet on the beam that I'm finding the weight of. I'm going to be multiplying that by 10, and it's right here. So I'm going to say that the weight of the middle beam, actually, let's go ahead and use the reference. The S5 by 10, he is going to be equal to 8 feet long times 10 pounds for every running foot. So he's 80 pounds. So that means that the weight of the total beam, is equal to 387.6 plus 144 plus 80. I already have the 144 in there, so it's plus 80 plus 387.6, and I get 611.6 pounds. And that's the weight of this entire beam.